Flow control statements in Golang for loop. Golang has only one looping construct, the for loop. The basic for loop has three components separated by semicolons. The init statement, this one here, this executed before the first iteration. Then we have the condition expression, this evaluated before every iteration. Then we have the post statement, this executed at the end of every iteration. In the init statement, we often use the short variable declaration, and the variable declared there only lives inside the scope of the for loop. That means only within these curly brackets. We can't access this I variable outside the for loop. This for loop will stop iterating once this condition returns false. Let's take a look at this sample for loop. Here we have init I with 0. Then we have a condition to check whether the I is less than 10. If I is less than 10, we go inside the for loop and print the value of I. After that, we increment I by 1. At the beginning, I is equal to 0, so this condition will be true. So we'll print the value 0. Then we increment it by 1. Then it will be 1. And again, the condition returns true. Then we print value 1. Likewise, this will goes until this condition return false. Let's run this. At the last iteration of this for loop, I will equal to 9, as we can see here. Then this for loop try to increment it by 1. Then I will equal to 10. So this condition will be false. After that, this for loop stop iterating. In Golang for loop, we can remove this init statement and the incremental statement from this line number 7, like this. This for loop will work as usual. Let's try to run this. As you can see, we can use this format as well for the for loop. Then we can use this I after the for loop ends, like outside the for loop scope. Let's try to print that as well. Here, now we can print I when it's equal to 10. In this for loop format, we can use this for loop as a while loop, like while loops in Java or C. If you omit the loop condition, it loops forever. Another flow control statement, if and else. In Go, if statements are used to make decisions in our code based on the condition. If the condition evaluates to true, the code inside if block is executed. If it is evaluated to false, the program will skip the if block. Unlike in many other programming languages, Go does not require parentheses around the condition. But the curly braces are mandatory if there is only one line of code inside the block. Here we have a simple example about the if block and how it works. Here we have int variable age initialized with 18, and we have a if statement with the condition if age is greater than or equal to 18, we print you are an adult. Here our age variable keeps the value of 18, and the condition age is greater than or equal to 18 is true. So this program will print you are an adult. If we change this age to like 14 and try to run this, then this if block will not executed. We can also include an else block to handle the scenario when the condition is false. Condition in the if statement false, and the program will skip the if block. Then the code inside the else block will execute. Here we have modified our example code to include an else block. Here we have age as 14, then the condition in if will false, then the program will not go inside this if block. It will skip the if block and go to else statement. Then the text inside the else statement will print like this. Now we can modify this with short if statement in Golang. Let's see how we can do that. We can remove this age variable declaration and initialization here, and we can include it inside the if block, and we can separate it from the condition by using a semicolon. Let's try to run this. Here this program also work as previous one. Let's try to increase this to 18. Let's try another value. Here this age variable will only live inside this if else block. We can't access this age variable outside the if block. Another flow control statement, switch. In Go, switch statements are a clean and efficient way to execute code based on a multiple conditions. They are similar to series of if-else statements, but often more concise and readable. This is the basic structure of Go switch case. Let's take a look at what are the key features. No need for break. Unlike many other languages, Go automatically breaks out of the switch after the first matching case. Default case. The default block is optional and runs when no cases match. Switch without an expression. You can omit the expression and use a condition in the case block. Let's take a look at this sample code. First, we have initialized a variable day, which is a string and keeps the value Tuesday. Then we have initialized our switch case, which triggers based on value of day. we have cases Monday, Friday, Saturday, and default. Let's run this and take a look. Here it's print, it's a regular weekday. This is the default case because Tuesday doesn't match with any other cases, Monday, Friday, or Saturday, or Sunday. Let's change this value to Friday. Now it's print almost the weekend. Let's try to change the value to Sunday or Saturday. Let's try Sunday. Now it's print, it's the weekend. Same for the Saturday. Switch without an expression. Here, the switch does not evaluate a single expression but checks multiple conditions in the case block. Let's try to run this code. Here, the age value is 20, so it must come to second case and print you are an adult. Let's try to change this to something above 60. Now we are getting you are a senior citizen. If we try to change this to 12, it will print you are a minor. We are going to discuss about another set of flow control statements in Golang, specifically fall through, type switch, multi-value cases, and self-init switches. By default, Go automatically breaks out of the switch after the first matching case. However, you can use fall through keyword to explicitly continue to next case regardless of whether the condition of the next case matches. In this example code, we can see that case 1 and case 2 have the fall through keyword as its last line, but we can't see the fall through keyword in case 3. If we have fall through keyword in case 3, it will go to default case as well. Let's run this code and have a look. Here we have our sample code. Here we have integer variable number which initialize using 2, and we have our switch case. As our number equal to 2, case 2 will trigger and it will print number is 2. Then as we have fall through keyword in the case 2, it will go to case 3. Then it will print number is 3. Let's run this code. Then let's try to add this fall through keyword to case 3 as well. Then it after printing number is 3, it will print number is something else as well. In Go, you can use switch statement to check the type of an interface variable. This is useful when working with dynamic types or when a function returns an interface. This is the basic structure of type switch. Let's take a look at a sample code and understand this further. In this example, we have our describe function which takes an interface as its input parameter. Then we have our switch case. In switch, we have i.type which gets the type of I interface and assign it to v, and according to the v's value, these case will trigger. In the main method, we call describe function with different values of different data types. Let's run this code. Here, as we first call the describe function using 42, it will print this is an int. Then for hello go, it will print this is a string. Then for true, it will print this is a boolean. Let's change this code a bit and try to send a float value here. Then we don't have any case which matches to float, so it will print the default unknown type. A case block can handle multiple values by separating them with commas. In this example, as the first case we have ABC. If grade matches any of these cases, it will print pass. Otherwise, if grade is DOE, it will print fail. Otherwise, it will go to default case, invalid grade. Here we have our sample code. We have variable grade, which is a string and keeps value B. Then we have our switch, which triggers upon grade value. Then as the first case, we have B, A, B, and C. It will print pass. As the second case, we have D and E, which print fail. As the default case, we have invalid grade. Let's run this first. It will print pass because we have B as our grade. Then try to change this to E. Then it will print fail. For any other value like F, it will go to default case and print invalid grade. If we need to add D to first case, make B grade, D grade for pass, we can move it to first case like this and try to change this to D. Then for D, it will print pass. In Golang switch cases, you can include an initialization statement before the switch expression. We can do this in if statements as well. Here in this example, you can see that we declare and initialize age variable inside the switch case block. Let's run this code and take a look. Here we have our regular switch case, which doesn't have any initialization statement inside the switch case block. Let's run this. It will print you are an adult. Let's try to include this initialization statement inside the switch case. For that, we have to initialize it after the switch statement, and after the value we have to add a semicolon, otherwise it will print an error. Same result. In this way we can do the initialization inside the switch case block as well. Finally, these are the key takeaways from this lesson. Use fall through for sequential case execution when needed. Type switch make handling dynamic types easy. A single case can match multiple values. Initialization in switch can produce boilerplate code. Another flow control statement in Golang, differ. In Golang, the differ keyword is used to postpone the execution of a function until the surrounding function returns. It is commonly used for resource cleanups such as closing files, closing network connections, or unlocking mutexes. This is a basic format of how we use differ in Golang. We use differ keyword in front of the function call. When a function is deferred, it will execute just before the function exits, regardless of whether it is exits normally or due to an error. Let's take a look at the example code. Here we have our example code. In our example code, in line 6, we have our first print statement, which prints start. Then line 7, we have print statement with differ keyword in front of it. Then in line 8, we have our last print statement, which prints end. According to the theory, differ keyword defers the function execution until surrounding function returns. So, as a result of this program, we can think that first we get the start print, then the end print. At the very last print, we will get the deferred statement. Let's try this. Yeah, we get that as we expected. In this example, we have multiple differ statements inside a single function. When we have multiple differ statements inside a single function, those differ statements are pushed into a stack. When the surrounding function exits, those pushed function calls executed in reverse order, last in, first out. Let's try to predict the end result of this program using that theory. First, we push the fmt.println first to the stack, then fmt.println second, then fmt.println third. Then we can visualize that stack where the fmt.println is at the very top of that stack. As we don't have any differ statement in front of the fmt.println main function, that statement will execute first. Then we pop that stack in the way last in, first out. Then last in is fmt.println third, then we print fmt.println third, then second. At the very end, we have fmt.println first, then that fmt.println will print at the end. Let's try to run this program.
Use cases of differ. Closing files. One of the most common use cases for differ is closing a file after opening it. In this example code, we open a file called example.txt. Once the required operation done on that file, we call file.close with differ keyword to make sure that the file close will call after the function exits. Unlocking mutexes. If you use Go routines and shared resources, differ can be useful for unlocking a mutex automatically. Here we call mutex.unlock with differ keyword in front of it to make sure that that call will execute after function exits. Recovering from panics. Differ can be used to recover from panics and prevent program from crashing. Here in this program we have anonymous function for do the panic recovery for this program, and we call that anonymous function using differ keyword in front of it. So when this surrounding function exits, that deferred anonymous function will execute and recover this program from crashing. These are the key takeaways from this lesson. Defer postpones execution until the function exits. Deferred functions execute in last in first out order. Useful for resource cleanup. Helps recover from panics to prevent crashes. Advanced use cases of differ. Advanced use cases of differ in Golang. Now that you understand the basics of differ, let's explore some advanced real-world examples where differ can be practically useful. Benchmarking execution time, logging function exits, cleaning up temporary files, differing loops, handling database transactions, graceful shutdown in servers. As we are still in programming fundamental stage in this video series, I'm not going to dive deep in these topics, but I will go through one by one with some code snippets. Later in this series, I will explain this once again in detail. Benchmarking execution time. You can use differ to measure the execution time of a function. In this code example, we can see that we have a main function. As the very first line of that function, we have start variable, which initialize with time.now. Then we have our differ anonymous function. Inside that anonymous function, we have variable called duration, which calculate time since the start time. Then we print it as a execution time. Outside the anonymous function, we have some sleep timeout to simulate some work done here, like time consuming work. After that done, we print work done. Why we use differ here? Differ ensures that execution time calculation happens after the function completes without cluttering the main logic. Let's run this code. Logging function exits. When debugging or tracking execution flow, differ can log when function enter and exit. In this code example, we can see that we have a couple of functions. One calls another and that one calls another function and returning values here and there. This kind of flow kind of difficult to track in real world scenarios. So we use differ here. Differ helps to track function execution and makes debugging easier here. Let's run this program and see what happens. Let's run this program and see how the logging works. Cleaning up temporary files. When working with temporary files, differ ensure they are deleted automatically after use. In this code example, uh, inside the function main, at the very first line, we create our temporary file. Then we have some error handling. I will discuss about this error handling in upcoming videos. Then we have differ statement to remove the file. Then we have differ statement to close the file. Remember, differ stack. Then we have our print statement, temporary file created with file name. Why use differ here? It prevents resource leaks and ensure temporary file doesn't accumulate. Here we have our code example. I have done simple modification to simulate some work here at line 18. Let's run this. We can see that file is created and after some time that file is gone. Differing loops, capturing variables. Sometimes when differing inside a loops, variable scope can lead to unexpected behavior. In this code example, we have our main function. As the first line of the main function, we have print statement, differing loops execution. Then we have our for loop. Inside that for loop, we have another print statement which comes with differ keyword. This is the output of this program. We have deferred 2, deferred 1, then deferred 0. Why does this happen? Defer store the variable of I at the time it executed. Since defer follows last in first out order stack, the last deferred statement runs first. Let's run this program and take a look at it. Let's run this program here. At the very bottom of the stack, we have deferred 0, then we have deferred 1. At the very top, we have deferred 2. Last in, first out. Handling database transactions. In database operations, differ can ensure transactions are properly committed or rollback. Here in this code example, we have created a connection to PostgreSQL database. Then we defer db.close to ensure db connection is closed at the very end of this main function. Then we start a transaction. Then we defer transaction rollback. We use rollback if something went wrong. Then we work on some database operations. Then we commit that transaction. Why use defer here? Ensure database connection is closed after execution. Ensure transaction is rolled back if something went wrong. Graceful shutdown in servers. When running a Go web server, you should gracefully shut it down when the program exits. In this code example, we have create HTTP server which listen to port 8080. Run the server in separate Go routine so the main thread is not blocked. Call server.listen and serve to listen for the HTTP request. If the server encounter an error, it print an error log. Then we have our graceful shutdown handling. Create a channel stop that listen to OS signals. Signal.notify function will captures any control plus C or termination signals. Ensure that the program can handle shutdown signals properly. The main thread blocks here until it receives termination signal. Then it print shutting down the server. Then we defer the server.close. Why use defer here? Ensure server resources are properly freed when application stops. Let's run this code and take a look at it. Here we have our example code. Let's run this. Then the server will start on port 8080. Then we press Control C to send some interruption signal. Then it gracefully shut it down and free the resources. Key takeaways of this lesson. Defer helps with cleanup tasks like closing files, unlocking mutexes, and releasing resources. Deferred function execute in last in first out order. Defer simplifies error handling and recovery using recover. Useful in database transactions, login, graceful shutdowns, and benchmarking execution time.